Konnichiwa friends, welcome to day 2 of the 100 days of deep learning practice. Okay, in this video we are going to see about the tensors and we will be practicing tensors for this video. Okay, this is a beginner level practice session, so it will be very easy for if you have just started learning tensors or the deep learning or the new students. Okay, so here I welcome you to the part of beginner practice session. Remember that if you don't understand anything, just check my lecture again or any lecture in the YouTube, or you could also search on the internet or chat GPT. Okay, solve exactly the 5 type of problem of that type and you could come back again. Okay, also for optional thing, do 5 push-up as punishment. Okay, if you don't understand that thing, also you could check the entire question list and answer list here, and also the theory PDF from my GitHub. Okay, so let's start our session. Okay, first we'll be importing the important libraries here. Let's run it. Okay, so now it's working. Now the first question asked here is that create a one-dimensional tensor with the values 1, 2, 3, 4. So like since we already imported torch, we will be directly creating a variable name t1 equals to torch dot tensor, and inside it we will pass the value 1, 2, 3, 4. Okay, this one will be very easy. I will be printing this one. Okay, so you could see that I print a tensor of 1, 2, 3, 4. Okay, for dimension, if you want to check, then t1 dot n dimension. Okay, so you could see that it's an one dimensional tensor. Okay, for help in the exact value, we are making a global function named def d name. Okay, and here it takes an tensor 1 and it print the tensor 1 and also prints its dimension tensor 1 dot n dimension, and also print the tensor shape. Okay, this is just a global function to so that we don't write repeating code. Okay, so we first run it here, run, and then d of t1. Okay, I think tensor 1. Okay, sorry, tensor 1 so yes, now it's working perfectly. Okay, so this d function we will be using in the entire our notebook, so keep mind of it. Then the question asked is create an 2D tensor of shape 2 by 3. Okay, so we could directly put it outside torch.tensor, or we could use the random value here. Okay, so you know the name RAND with rows and columns here, okay, and it will print our two-dimensional tensor, okay. You could see here the tensor and its dimension and its size, okay, 2 by 3 matrix. So this is how we could also make, also like if you want to make the normal random distribution, then you pass RA and DN, okay. Here it was talk about in the theory.pdf, okay. Let's see, just a second. Until it's loading, let's get to question C, where we have to create a tensor from a Python list, okay. So basically here is saying to use NumPy. So how do we create a list in NumPy? Do you know it? Basically we write here array as a variable name, then we write np.array, and here we pass the list here, okay, 10, 20, 30. Now this will be an NumPy array, okay. To convert it into tensor, we use toss.from NumPy function, isn't it? Array, then we check with our d function, okay. So yes, it's working fine. We could see the tensor here, its shape and its size, okay. Here I don't know what is happening with, I have like downloaded it here, okay. So you download it directly using this button. I think it's not working here. So here we understand about 5 types of creating it, and the random values come from here, okay. The last one, toss.random 2 by 3, and here from NumPy we talked about it here, okay. Now in the question we were asking about to create an tensor of zeros with shape 3 by 3. So you know how to create it using toss.zeros, zeros, and 2 by 3, and it will print 0 tensor in 2 by 3 matrix, okay. We talked about it here, this one, toss.zeros, okay. For ones, empty, full also we have the thing. Now here it is asking to create a tensor of random value of shape 2 by 2. We had already done this. t5 equals to toss.random 2 by 2, and we then print here t by 5, and we get this value, okay. From here it's coming. Then come this section 2 part, okay. Section 2 is about the tensor shape and dimension and type, okay. Given a tensor toss.random 3 by 4, okay. So this one is a tensor, and we have to print its shape and its dimension, okay. So you know the syntax here, we had make it inside the global function here. So the syntax is very clear here. First tensor, then for shape we write shape, and we could see the shape here, okay. Then for the dimension we write here first tensor and then n dimension to get the tensor dimension here, okay. Now here change the data type of tensor from int to float. Okay, like we create a new variable, and here we take this tensor and type float directly. Okay, and it will typecast the entire value to tensor. Okay, I mean float. Okay, so here you could see the value is changed into float. If you want int, you could directly put here int. Okay, now here it is asking to reshape a tensor of shape 2 by 3 into 3 by 2. Okay, so we create a new tensor named T7. We write it tors dot random 2 by 3. Okay, then we have to reshape it here. Okay, we will be printing this D7, then T8 will be about this. Okay, T7 dot reshape into 3 by 2. Okay, DT8, here it is T7. So by using the reshape method, we could rearrange our matrix. Okay, it was also shared inside this one. Okay, this first thing one x dot reshape here. Now we have to create a scalar tensor and check its dimension. Okay, so you know what is scalar. Scalar, this one. Okay, scalar mean basically a number. So we create torch dot tensor and we put like any number here. Okay, like we say 99, then we print this tensor and get our value as 0, which is a scalar tensor. Okay, and size we get null since it's a scalar. Now coming to this section 3 part, which is about tensor operation. Okay, first it is asking to perform element wise addition of two tensors. Okay, so first we create two tensor name A, which we name tors dot random 2 cross 3, and for B we also do the random here. Okay, random 2 by 3. Then for C we directly plus it and we print it. Okay, so let's see, it's working fine. Okay, we got the final tensor as this. If we want to directly see the value here using our global function, we see that 0.5512 is the direct addition of these two here. 0.2592 is the direct addition of these two here. Okay, we could also here directly minus it. Okay, we could also do it. It was told in the mathematics part. Okay, now we have to do an matrix multiplication. Okay, so we create an tensor into this one, and B we are basically making ones. Okay, 3:2. 3 is to t. Okay, see, we are doing mat mul function tos dot matrix multiplication. Okay, a and b, and there will be printing c. Okay, so we see here that the matrix multiplication was successful, and the c have the rows of the first column, I mean rows of the first rows and column of the second column. Okay, so this is how the matrix multiplication is done in the tensor. Okay, now it is asking to multiply a tensor by scalar. Okay, example, tensor into 5. Also you could also put here like ones, not random here also. Okay, and you will get the exact same thing. Okay, basically ones random values doesn't matter, the matrix multiplication does. Okay, here it is asking to multiply a tensor by scalar. Okay, so here we multiply a directly with 5 and see it. Okay, so here we see that a was 0.3771 and we multiply it with 5 and get the 5 times of the value for each tensor here. Okay, so the entire multiply by tensor by scalar is successful. Okay, now it is asking to find the mean of the tensor. So we will be printing the mean of the tensor as a dot float dot mean. Will it work? Yes, 0.5137 is the mean of this tensor. Okay, the a tensor. Now it is asking find the maximum value in a tensor. Now you may be asking that why we do here float here. Okay, so like we need, so I mean the mean, median, maximum or minimum values always work on float values. Okay, so we need to typecast the tensor to float to do an statistical operation. Okay, here also we do the same. Here we will be printing a, then we will converting to float, then we will printing its maximum. Okay, we get 0.9733 as the maximum, which was here. Okay, in the first rows, second column maximum was there. Then we move on to section 4 of the broadcasting. Okay, now you have to add a tensor of shape 3:1 with a tensor of shape 1/3. Okay, so now coming to the broadcasting part here. Okay, here the question it is asking is that add a tensor of shape 3/1 with a tensor of shape 1/3. Okay, so we create a tensor name t1 with tos dot random variable with 3/1 shape, and then we add here with 1/3 shape. Okay, now here you could see that the shapes are very different for these two. Okay, but during the broadcasting here, okay, we will be basically adding the whole row wise and column wise operation here. You could see when I will print the three things from here. Okay, t3, here you could see that first is 3:1, which basically means that we have 3 columns and we have 3 rows and 1 columns, and for T2 we have 1 rows and 3 columns, but when we plus it we will be adding row wise operation. Okay, for example 0.6144 will be added to 0.5344. For here also the same 0.6144 with 0.1845, and then the 0.7832 with the 0.6144. okay, for whole column, and the final we will be getting is like the matrix multiplication of the rows and columns interchange. okay, so here the row will come from here, and here the column will be coming from the B part of the tensor. okay, this one is important. Also the second question comes is add a scalar to a tensor. This one is also easy. Here we will be defining an T4, then we will be adding just 1. okay, T3, and we will be adding just 1 and we printing it. okay, so we see that here 1 is added to each element inside the tensor. okay, so then this is how tensor is added to an scalar. okay, it was talked in here also. okay, for single, for multiplication and the matrix multiplication. Now this one is just in question. Now the section 5 is about the auto gradient and the gradients. okay, this one is talked more below here. okay, the auto gradient part. Now it is telling to create a tensor with required gradient equals to true. okay, so we create an one dimensional tensor called, let's say 7. okay, torch dot tensor 7 with requires gradient equals to true. Okay, so since we have gradient on here, I think requires gradient. Okay, sorry, here the basically we had to make it float type. okay, here we see that we have a float and we turn on the required gradient here. okay, now we compute y equals to t to the power 2. okay, when we will be printing both the value here, we see here that 7 to the power 2 is 49, but here the t remains unchanged. okay, but as soon as I click on y dot backward, okay, BACK backward, so sorry for the interruption. Now we created here 7.0 as the tensor, then we power it to 2 and save it to y. okay, now it's saying to call backward for the back propagation. okay, backward, and then we have to print the value of the gradient here. okay, so when we print, we see that it t now became 14. okay, so basically here it was, one second, here it was x to the power 2. so after the differentiation we get 2x, and since x was 7 we get 7 into 2 equals to 14. Okay, so this is how basically it work at that time. Okay, now this section 1 of the part B. Okay, we have to create a tensor with 10, 20, 30, 40 and 50. Okay, so we create an t1 name and we write torch dot tensor, and here we provide 10, 20, 30, 40, 50. Okay, then we need to here access third element. Okay, so we print t1 and we have to access the third element, so we put here 2. Okay, and here we see that the third element was 30, so we get the answer as 30. Okay, is the basically the same as any string operation or the numpy operation. Okay, now we need to slice first 3 elements from the tensor. Okay, so how we do it, we print it, we print t1 from 1 to 3 na, so we type 3 here. Okay, like simple string here, we get the first 3 element normally. Now we create into this tensor t2 equals to torch dot random 3 cross 3. Okay, now we need to access here the row 1 and column 2. Okay, so we write it directly from here. Wait, first let's print the value. So we need to get row 1 and column 2. Okay, we need to get 0.4869, so we do here basically n minus 1 to get the value. Okay, 0.4914 and 0.4914. Okay, first row, second column, we get the value by this. Now get all row but only second column. So here we need to basically print all rows but second column here. Okay, so we need to print only this thing. So first we get the entire for t2 for all rows, and for columns we provide only 1. Okay, for second column, and finally we get this. Okay, 0.4914, 0.0058 and 0.4179. Okay, so this is how we do it. Now it is saying to create a tensor and select only even number using masking. Okay, so we need to create a tensor t3 equals to torch. Now let's create tensor using our arrange value. Okay, torch dot arrange from 1 to 7 with step size of 1. Okay, so we see here as the what happened, torch dot arrange. Oh sorry, here only 1 hour and we get 1 2 3 4 5 6. Okay, then we need to select only select only the even number. So we do here t3 and we mask here where the t3 modulus 2 equals to 0. Okay, we save in t4 here, and basically it's the same way how the pandas work. Okay, the pandas data frame here, and then we print the t4 here, the t4, and we get only the even numbers here. Okay, so basically the masking works the same way as in pandas. Okay, there's no difference. Now we need to replace all value which is more than 3 with 0. Okay, so we do the same masking where here t3, where t3 is more than 3 should be equals to 0. Okay, then we print it t3 here. Okay, so we get the final value is 1 2 3 0 0 0. Okay, so basically it working the same way as the pandas. Now we have to check if a tensor contains value 4. Okay, so we print it directly and t3 dot contains I think I have forgot it. T3 equals to 4. Okay, so my mistake, I had forgotten it dot any. Okay, so yes, I will be doing 5 push-ups today. Okay, so here we get the tensor as false. Okay, we check the entire dataset to have equals to 4 if any, and since we have no 4 here, we get here false. Okay, now here we need to count the number of elements which is more than 2 here. Okay, so we take the tensor and we do more than equals to 2 dot sum, and we get the value here. I think an extra column is coming, and we see here that there is only 3 and only one element is there. Okay, in 3, what if we do this again? Okay, like get the 1 2 3 4 5 6 here, and then we, instead of replacing, we check whether we get the value as 4 or not. So we see that now is true, and here the number of element more than 2 will be 4. Okay, so now we see that it's working fine. Okay, for this thing. Now the shape manipulation, create a tensor of shape 3 and convert it into 1 by 3 using unsqueeze. Okay, so we know that this is an one dimensional tensor. Okay, with 3 values. So we take t8 equals to torch.tensor, and we create here 1 2 3 values. Okay, and then we print this value, and we see that the shape is the same. Okay, now what we are basically doing is that we will be unsqueezing to add an extra column in the first thing. Okay, so you will see this directly when we do unsqueeze. Okay, unsqueeze, and we will be putting it in 0. And now let's see our value. Okay, I think unsqueeze, this spelling is wrong, unsqueeze. So yes, now you could see that t8, I forget to did it. Yes, now you will see that here the shape was 3 only, but here after we unsqueeze it add an extra column here. Okay, so like you could see here we have our matrix. It was changed to this. Okay, so it basically add an extra dimension to our element. Okay, here if you have done like a random 2:3 and unsqueeze it, you could see that it add an extra dimension to here. Okay, like it was 2/3, now it get to 3. Okay, when we add the extra dimension here, the 3 here, then it add the extra dimension 4 here. Okay, so this is basically how it work. Okay, it basically add an extra dimension to our tensor. Okay, for getting the value back. Okay, for getting the value back, we do the entire same thing here, just we unsqueeze it. Okay, so T8 equals to T8 dot squeeze, and then we print it and see this. Okay, squeeze spelling is right, yes. So now we finally get the final value. Okay, the value back. So basically squeeze and unsqueeze works this same way here. Okay, here we have talked about it. Okay, now comes the add dimension at index equals to 1 to tensor 3/4. Okay, we need to create a new tensor, then tors dot random, we pass 3:4 matrix, and it is saying to add dimension at index equals to 1. Okay, so here we will be unsqueezing it, unsqueeze. Okay, unsqueeze, and we will be adding it in 1. Okay, so the printing this, and after unsqueeze we will be printing this. Okay, so you will see that it increase the dimension, but here instead of adding extra dimension at the first, it add extra dimension after the 3 here. Okay, you could see here, if we would have done here T10 equals to tors dot T9 dot unsqueeze 0. Okay, and if we will be printing this thing here, then you could clearly see the difference. Okay, here we add an extra dimension here. Okay, when we put it 0, but when we put it here, it add the extra dimension inside the 3/4, in between 3/4. Okay, so this is how basically we add an extra dimension. Okay, finally comes the tensor sorting part. Okay, we have a tensor, then T1 equals to tors dot tensor 3 1 4 2, and we need to sort it. Okay, so this one is very simple. We just call the sort function, and it will automatically sort it. Okay, so since it had no dimension here, we call it like this. Okay, T1 dot sort value. I think sorting function is fine now. Yes, I think it's tors dot sort. Okay, so 10 push-ups today. Tors dot sort na, tors dot sort, and we pass the no I think the number of dimension is not available for this thing. Okay, so we just print here T2 directly. Okay, basically the n dimension doesn't exist for sort. Now the B is that we have to get indices that would sort the tensor here. Okay, so for like indices you could get the indices from here directly. Okay, when we do here torch dot sort, we get the indices from here only. Okay, so this thing is also fine. Now C path, we have to sort the tensor in the descending order. So we create a new tensor and then we pass the torch dot sort value and we do the sorting, but here we will be doing descending equals to true. Okay, then we will be printing T3 here. We see that now the tensor is sorting in the descending order. Okay, at first it was in ascending order, but now it is in descending order. Okay, now we have to sort along rows of for a 2D tensor. Okay, so we create a new 2D tensor named torch dot random 2 cross 2. Okay, and we sort using torch dot sort T5 and here we say dimension equals to 0 and we print the T6 here. Okay, and we get with I think we need to also show you the tensor. Okay, so basically the tensor was 0.0693 to this and we sort it row wise. Okay, row wise. So first we get 0.0693, then 0.0205, then our 0.092 and then our 0.05327. Okay, so here basically we sort along the rows. Okay, if it was above the columns, we here would have typed dimension equals to 1. Okay, and it would have sort along the column. Now we have section 4, which is about stacking the two tensors here. Okay, like we are where, yes, this one is final part, so let's get through this part. So we create an torch dot torch dot random, and for T2 we also do the torch dot random 3/4 and then we T3 equals to torch dot stack T1 and T2. Okay, so basically stacking and concentration was told in this. Okay, here it should be inside a matrix and then we'll be printing the T3 here. One thing, okay, here these shapes should be exactly the same. Okay, here basically the 1 and 2 are actually and yeah. Okay, the list. Okay, here torch it was basically an leisure, okay, not the shape. Okay, then when we stack it, we get the value as t1 dot array tor dot tensor. When I told that we have to do this first, then only this thing is happening. Okay, so now we stack the whole thing one above the other. Okay, for like stacking it into dimension of 0. Okay, so by default the direction is equals to 1 0. Okay, but if you want the dimension for stacking to be 1, we have here property name dimension, which we send as 1, and then we print our t4 here. Okay, so now we stack it into column wise. Okay, now finally about the concat. Okay, so we create here t5, then we call the toss.cat and stack our t1 and t2 here. Okay, and then print t5. So yes, we finally concat the entire thing into an single linear tensor. Okay, so this is how basically how it works. Okay, now we need to create an tensor of 2x3 shape and flatten it. Okay, so we create an tt equals to tensor torch dot random of 2x3 shape, and then we flatten. Okay, so we directly call t8 and then we see this. Okay, t8 equals to dt8. Wait, I think t8 equals to, here we see that basically it works this same way as our cat here. Okay, here basically we have an matrix here, but we flatten it into a single one dimensional object. Okay, and this is how basically the flatten work, which basically flatten the entire matrix to a single row here. Okay, now we need to convert here the 2 3 4 matrix into 4 3 2. Okay, so we create a new matrix here named t9. We name here toss dot random 2 3 4. Okay, any random, and then in t10 what we done is t9 dot reshape, and then here we see that 2 is going to last, 3 is remaining the same, and here 4 is coming to the first. Okay, so here basically I here put the indices. Okay, and then I will be printing this. I think I had forgotten. Let's see the answer here. We have toss.random permute function. Okay, permute function, here it should be permute to get the final one. Okay, so you could see here we change into four batches, each have 3 rows and 2 columns here. Okay, so we basically, if you want to reset using permute, we do it by sending the indices here. Okay, now here it's asking is to transpose a matrix. Okay, so here is done simply by just putting it like t10 dot t. Okay, t means transpose and it will print the entire transpose of the matrix here. Okay, so we see here is 432 and here is 234. Okay, basically it interchange. Now we had already permuted it, so let's do it fast. Okay, t11 equals to torch dot random 2 3 4, then we print here t11 dot permute here, and here 0 is going to 1 here, 3 is coming to the first, and second column is same. Okay, so as I pass the indices, I got the value. Okay, now the final part of this thing is to GPU practice. Okay, so for this session you need the accelerator as the GPU. Okay, so I turn on the GPU and start this session. Okay, again. Okay, so here first thing it is asking is to create a tensor on CPU and move it to GPU. Okay, so first we need to create a device which was told in the hour here. Okay, this thing to create a device, we create a device, then device equals to, wait, what happened, it collapsed. Hello, I think it's working, but just a second. Yeah, it worked now. Device equals to, we get CPU and GPU from torch dot device. Okay, and here we write CUDA for our GPU or CPU for our CPU. Okay, but here we are passing CUDA if our torch dot CUDA dot is slash available, then only we'll be using CUDA, or else we will be using our CPU only. Okay, so here it worked until now, and we get here the device name here. Okay, print device, and here we see we are in the CUDA. Okay, so first here let's understand the question. We need to create a tensor on CPU. Okay, so by default every tensor is created in CPU only. Okay, so here v t2 equals to torch dot tensor 7.0. okay, and then we pass on t12 dot 2 and we put here the device name. Okay, and then we print here finally check the T3 device which is in CUDA. Okay, but here you need to understand that here the T12 is in CPU only. Okay, so here when we print it, we see that here the T13 is in our CUDA and our T12 is in our CPU. Okay, now we need to create a tensor on GPU only. So how we do? We during the creation only we tell that torch dot tensor, and here we name the device as device only. Okay, and then we print whether our T14 is in GPU or CPU. Okay, so here we see that we directly first make a tensor and send it to GPU only. Okay, now we need to create a numpy array 1 2 3 4, convert it to PyTorch tensor and move it to GPU. This is also very simple. We create an array. Okay, np dot array name 1 2 3 4, then we convert it into from numpy and then we then send it to our GPU. Okay, T15.2 device, and then after the print statement we generally see the device as our CUDA. Okay, so we create a numpy array, then we send it to our torch, and then we create our GPU. Okay, now we need to create a numpy array, convert to tensor using from numpy. It was already done. Okay, we need to check here whether when we change T5 first thing here to 66. Okay, here you will see that the array will also change here. Okay, so here even though I converted, I means initialize the tensor here which is T15 which is an tensor, it since it was about referencing, we also change the numpy array here. Okay, we talked about it inside the our clone versus here clone versus our referencing. Okay, here we are talking about it, so you should understand this thing. Okay, now here it is asking why does this fail. Okay, tensor dot numpy. Okay, you must understand that if this is in our CUDA. Okay, now if you are doing directly to numpy, okay, you can do it. Numpy print np, you can do it. Okay, np 0. Okay, np is just, you will see here an error that can convert CUDA device tensor to numpy. Okay, so to do this we pass this CPU function which basically send the tensor to our CPU, and then we do the numpy and then we get the final value as 0 1 2 3 4. Okay, so this is how the whole question answering is done, and I thank you for joining me in this course, and I will see you in day 3. I hope you learn some new things in this practice session. Okay, that's all for today. Bye bye.